Okay, good morning, everyone, and welcome to Autodesk Virtual Academy, brought to you by KETIV Technologies. Our camera is being borrowed by some other people right now, so unfortunately, you just get to hear the sound of our voices. I'm Nigel Mbai, Customer Success Manager here at KETIV Technologies, and this morning I'm joined by my good friend and colleague here, Alex Alvarez. How's it going, Alex?
Not too bad. Not too bad.
Nice. Alex is one of the application engineers here on our team, working primarily on the post-sale side of things, helping customers with their projects and doing numerous trainings and so on and so forth. But one of Alex's passions, I guess, is manufacturing. That's part of what you started doing here, Alex.
Yeah.
If I remember correctly.
Absolutely. Yeah, that's actually what I got hired on for. Just mostly just manufacturing, working with HSM and some of the Autodesk manufacturing tools.
Yeah, and then we found out you're good at other stuff, so we just maybe do that as well. But yeah, we're going back to your roots, I guess, today, going into the Inventor nesting utility, something I know a little bit about, but I think you can elaborate a little more than I can. So with that, let's just hop straight in. If anyone has any questions about the nesting utility, the workflow, need us to slow down, speed up, let us know in the Zoom questions here, and we're more than happy to do so.
All right, perfect. Thank you for that. So let's go ahead and get started here. Kind of like Nigel mentioned, we are going to be talking about nesting, but also adding a little bit more to it as well. So again, before we do dive right into it, we'd like to start off with the why to these webinars. So one of the biggest reasons why we're doing it is not only because our customers or some of our viewers are asking to see these topics, but we also want to kind of highlight or pinpoint how you can increase the design and manufacturing efficiency and accuracy. So what I mean by that is you have your sheet metal components. Let's say you're manufacturing in-house in this case. Maybe you want to create your flat patterns. You want to start nesting them. There's many different ways. A lot of people tend to create their flat patterns and export to AutoCAD. What we want to highlight today is really how you can leverage the tool that you use to design all of your data and use that to create essentially a nested product, right? Or just create a nest of your entire assembly in this case. How to better understand the nesting utility. So again, it's a relatively new tool that was built into Inventor not too long ago. So again, it's still gaining some traction. There's still a couple questions in there that people aren't too sure of. So hopefully we can highlight some of those questions as well today. And really lastly, how to kind of tie everything back down to manufacturing. So again, we have our assembly, we have our flat patterns, we created a nest for it. How does that look like when we transfer that over to a computer-aided manufacturing software? So in this case, we are going to be looking at Inventor HSM. Again, what are the benefits to using Inventor HSM, being that it's embedded in the software, and again, using the same tool or leveraging the same tool that was used to design these products. So again, starting off with Inventor nesting, with Inventor nesting, that's really going to be a two-step process. So the first step is really going to be a shape extraction. Now, what I mean by that, shape extraction, so Inventor nesting utility is going to look at your models or your sources in this case. It's going to see if there are any closed 2D loops, and then it's going to start extracting those shapes. So there are a couple rules happening in the back end. So different ways that the nesting utility is going to be able to pull out some of these shapes or extract some of these shapes. Just know that there's a couple rules. One of the rules is going to be it's going to look for the closed 2D loops, and it's going to try to extract from that. If it doesn't see that, then it's going to try to go into the features and then try to extract those shapes as well. So that's really going to be the first step. The next step that it does is obviously it starts creating the nest based off of those 2D extracted shapes. So again, just getting a little bit of a understanding of what's taking place in the back end when you actually start creating a nest. So the nesting methods. So actually, the nesting utility creates .inest files, and that's really the nesting utility's own file in this case. There's a couple ways that you can create one of these .inest. In this case, it's going to be three methods actually. The first one is going to be using the nesting ribbon. So once you actually download the add-in, or once you have the add-in installed, it's actually going to be in the top ribbon where you would see the cam tab or some of the other tabs that are are pretty familiar to you guys. So that's going to be the first method. The next method is going to be actually creating it from inside of the IPT or the assembly file. Again, so we're going to highlight some of these methods. Really, the last method would be, how to create a new template. So once you go to a new part, you can start and then select, kind of start from scratch from a template that you have created. So I'm going to highlight a few of these and kind of show the workflow of what these look like. So again, ask questions. Feel free to, we'll do our best to kind of ask or answer some of these questions as we're going along. But if we can't get to it, then we'll get to it in the appropriate Q&A portion at the end of the webinar. So let's go ahead and get started here. So for today, we are going to be looking at this slot machine. So reason why we're selecting this slot machine is because it has a few different components. So one of them is going to be the slot stand, and that's what we're going to be looking at. Now, what's interesting about the slot stand is that it's made out of wood, right? So we zoom in here, we can see that it's slightly different material. It's got a few different unique shapes. It's got these corner joints, which we'll see how the nesting utility handles these. And it's got this overlay of rubber on the top as well. So, we'll see how that interacts with the nesting utility as well. And then we'll move over to another component that's actually inside the slot machine. And that one is strictly made out of sheet metal. So again, we're going to encompass both wood components and sheet metal components in this case, just so that we see, what that's going to look like. So with that being said, let's go ahead and close this up. And again, we're going to go ahead and open up our slot stand here. So I'm going to go. And here's the slot stand, right? So again, it's made out of different components here, different unique shapes, different ways that you can really approach this. So again, like I mentioned, this is going to be one of the ones that we want to go ahead and make sure that it doesn't get transferred over to our nesting utility. So again, 3 methods on how to create a actual nest file. So the first one would actually be if you come up here and you right click on the top node and you create a nest. For this one though, I think it's going to be a little bit more easier if we take a look at what happens up here at the top, right? So we're going to start off at the very home page. And like I mentioned, once you have the add-in, you're going to have that nesting tab that you can then select, and it's going to essentially just give you a new kind of toolbar here. So the workflow that we're going to follow is honestly, it's pretty straightforward. It's going to follow really any other workflow that Inventor has, in the sense that we're going to start from left to right. Really, the main panels that we want to focus on are going to be the shapes panel, nesting study. Display is pretty useful, but again, the biggest one here is going to be the manage one, nesting study, and the shapes panel. So once we have this kind of laid out, the first step is going to be, okay, what source are we going to select to create or start extracting shapes from? So in this case, we want to go ahead and select our source file. We have our slot stand already predefined here. And it's going to start extracting all the shapes as we see it in the assembly. So first thing that it's going to pop up, it's going to say, okay, well, we detected a few materials. These are the materials that we detected. These are the thicknesses. Are you okay with that? And we are in this case. So we can go ahead and say yes. And that's next thing that it starts doing is it starts extracting those shapes. Now again, you want to make sure that you wait so it hits 100%. If you start, clicking anywhere else, you might start running into some issues. So you want to make sure that you have 100% extraction here, and then you're going to be ready to go. So biggest thing here inside of the sources dialog box is it just pretty much lays out, okay, so where is that assembly coming from? So obviously it's coming up from the slot stand assembly, what the source is, the units that it was created in, right? So kind of the overall high level information is located in this case. Again, source provider, right? So what kind of source is it coming from? In this case, it was modeled inside of Inventor, so it's going to be an Inventor part. So we are going to talk a little bit about what kind of sources we're allowed to bring in here. And then, what kind of configurations. So configurations we'll probably get into either down the line or maybe in a different webinar, but that's also going to be pretty important. So in this case, notice that if we take a look at the very left-hand side, we see green check marks all along the different sources. So that means that we're good to go. So we can go ahead and say okay. And it automatically extracted all the shapes here, right? So again, if you take a look at it, it's just a 2D representation, right? And that's where a lot of people get confused, because they're like, well, you know, I had a 3D model. Why is it just bringing the outline of it? And again, that goes back to what it's doing in the back end, right? So it's extracting these 2D shapes and it's bringing them into the nesting environment. Now in here, a few things. So I guess the nice thing about this is that it remembers some of the options that you select. So right now it's pretty organized, but if it's going to be your first time actually running the nesting utility, by default, if we go ahead and select sources, click OK here, and then material, set that to default. This is actually how it comes in by default. And again, you know, if this is your first time, or if it's going to be your first time running the nesting utility, you really don't see what's going on, right? So I mean, you see your parts obviously, but you can't see exactly, you know, what materials what. Are they coming from the same source, or what's going on with these different extracted parts? So that's why what I like to do first is go to the options, and then in here you have a couple options. This is mostly going to be for the display, and we'll see kind of how that ties into the display over here once we create a nest. But the biggest one here is going to be the sources. So we want to make sure that we check on sources arranged by material, and it automatically arranges them by material. If we go to the visibility here, we can go ahead and change that to material, and it's going to automatically kind of color code these extracted shapes to match what material we're going to be using. So again, kind of going back, what materials are essentially in here, or how do we know what material belongs to what part? Well, that's where the manage panel is going to come into play, right? So we're going to want to take a look at the process material library in this case. Make this a little bit smaller. And we can see that the 3/4 inch thick wood is going to pertain to this color or this nesting color, and you know, kind of so on and so forth. So we can start seeing what we don't see though, or it's not really too easy to see, is going to be the 2-inch thick wood maple, right? It's a little bit darker green here. So again, if we take a look at this, I mean, it's probably pretty straightforward to look at it down here. But another thing that you want to do, or you want to get comfortable with, is being able to find that unique component on the left-hand side. So again, this is all the parts that the nesting utility was able to extract. In this case, we know that it was a corner joint. If we click on it, it's going to automatically zoom into that part, right? So again, in this case, we're not going to necessarily want the corner joint. So we can go ahead and take a look at what that looks like, and where we take care of that property. So again, not too bad. Again, the biggest thing that we're going to want to take a look at before actually creating the nest is the nesting properties. So we can go to nesting properties, and again, it brings up a very similar dialog box to the source, but you know, something else that it adds on is going to be the source quantity. So here we can see exactly how many of these or how many of these were extracted from the assembly. Now these values, they are strictly getting pulled from the BOM, from your assembly BOM, right? So again, if you're trying to make an edit here, let's say you want maybe 3 of these slot stands, right? You can't type it, and that was done on purpose. That was done so that you know, you don't change you know, an object here, and then on your assembly side you still have kind of the original values. So if you do want to drive some of these values, you want to either do that once you create the nest or in the assembly BOM. And of course in here, you know, it lays out the material, what kind of thickness you're going to be using, the priority for how it's going to get nested, if it's going to be able to rotate, you know, if you want to deviate that by different angles, and really the last ones here are going to be the dimensions for those specific components, right? So again, if you ever need to maybe get an idea of how big your sheet size needs to be, based off of your components, you can take a look at the overall dimensions of the component inside the nesting properties here. But anyways, so we just took a look at the nesting properties. We made sure that we arranged, the correct parts here. Next, we would want to go ahead and say create, right? So in here, this specific dialog box looks a little bit scarier than it actually is, but it essentially just tells you what's going to get nested. Right here, we can see that we have all the different parts kind of selected in here. We can go ahead and deselect some of them, but what's going to happen is we're still going to have that packaging 3 trying to look or locate for that specific part. So instead of actually coming in here and deselecting it, we just want to go ahead and get rid of the entire packaging 3 option. Right? So we can go ahead and say right click, and I want you guys to take a look at what happens to the corner joint part. So if we click on packaging 3, we can go and say delete. Yes, we want to delete that. Deleted packaging 3, but it also unchecked that for us, right? And we'll talk a little bit more about some of these other options down the line, but we can go ahead and say okay. And it's going to automatically start generating those nests for us, right? So again, it based off of the sheet size that we have or that we selected for the packaging size, that's what it created, and it tried to fit the most kind of the most parts into that specific sheet size that we had. So when it found that it couldn't fit any more parts, then it went ahead and it transferred over and created essentially more sheets here. So that's okay, right? But in this case, let's say we know exactly what sheet size we want to use. What we can do, and we can take in here, kind of take a look at what's going on in here. So again, that's the name that we gave it, the efficiency, number of parts, and then the sheets for those individual parts, and then kind of the most important one here is going to be the material ID. Right? So we have material ID 2, and it's packaging 2. So let's say, okay, we want to go back to the process material library, and we can say material ID 2, packaging 2. Notice that we have a sheet size right now of 55 by 30. We can say, okay, well now we want this to be 100 by 50. Go ahead and say okay. So it updated that, but again, it didn't quite generate the nest for us. So what you want to do in this case is right click and just recalculate that. And it automatically calculated that nest for us. Now again, notice that I only changed the sheet size for the packaging 2, therefore it only updated the top packaging here. This bottom packaging, again, completely different material thickness. So again, let's say this is what that was the original sheet size that I had. So I'm just going to go ahead and leave it at that. So we're going to have essentially three different sheet sizes for this packaging. But really, that's going to be it, right? So now we have our nesting efficiency. It brought it up a little bit, 78.25. We have our nested parts in here. So really, the last step is going to be, okay, well, now we want to either export this as a DXF, or being the reason that we want to go ahead and highlight some of these workflows, we want to go ahead and create a 3D model from this nested environment. So again, we want to make sure that we click on the sheet. You can either click on the sheet in the environment here, or you can just select it over here on the left-hand side. But we can say, okay, let's go ahead and create a 3D model. Now, I think this is relatively new. I think before you didn't have the option to create assembly files, but now you have the option to actually create a multi-body part file or an assembly file. So if you select the assembly file, of course, you can select where you want to save that assembly, and it's really going to be up to the user as to how they want to manage these parts. So do they want to manage multiple files? Are they okay just managing one part file with multi-bodies in there? Are you maybe going to do some manual nesting? If you are, then I would say go ahead and do assembly file. Maybe you want to move some of these parts around. It all really just depends on what you're looking for. In this case, I'm going to go ahead and select multi-body part file just so that we can see what happens. But in doing that, it's really just a quick step. It just automatically generates that part file for us. It creates the stock material, and it kind of lays out these parts for us. Now, a few things that I want to point out is, this is a wood material, so we would probably more than likely machine this on a router. If we take a look at the spacing here, that's pretty tight spacing, right? So 0.197. Again, if you're machining with like an 1/8 inch end mill, then I guess that's fine. But I don't see anyone doing that. So that's something that we need to change. And the other thing that we would want to change is let's see that 0.394. So that's actually okay. I'm okay with the kind of the spacing that we have there. So this is kind of the only downfall to creating that nest. So once you actually generate that part, it's not going to update the part. You're going to have to recreate that 3D model. So that's something that you want to be aware of. Again, so what we would do here is we would edit the nest. So we would come up here. All right, so now we want the item separation to be, let's increase that a little bit to 1 inch. And we can say, so this is where that 0.394 value was getting pulled from. So if you want that to be spaced a little bit more, you can obviously change this or increase this if you like. But for me, I'm gonna leave it like that. I'm gonna say, okay. And it's gonna automatically generate that nest for us again, right? So again, once I made the separation a little bit larger, again, this part wasn't able to fit. So maybe now what you want to do is say, okay, well, I can go back to the process material library and say that's not going to be 100. Now that's going to increase to 105, just so that we have all of our parts kind of fitting in one single sheet. And then just recalculate that nest. Okay, so now we have essentially all of our parts laid out, and really the last step would be, once again, create that 3D model, right? Multi-body part file, and say okay. Okay, so there's our part. I'm gonna go ahead and close out the other one. So I'm not gonna go ahead and add any toolpaths just yet. I'm gonna kind of wait for the sheet metal one to get completed as well. And then I'll kind of walk through the HSM portion altogether. So that was kind of the quick and dirty way to to create a nest. Again, there's a little bit more details that you can play around with, but honestly, I mean, it's just going to be a matter of selecting your source files. Which source files do you want to do you want to omit? What the separation is going to be, what your packaging size is going to be, and then really just create that nest. Okay, so. And again, that was just looking at the method for creating the nest right off of the nesting ribbon. So now what happens if we want to go ahead and we have a specific part open? In this case, I think it was cabinet. Let's go and update the assembly. And start looking at this part. Right, so again, we have a part here, multiple different components that it can select. But really the nice thing about having the ability to create a template is that you can only select parts that are going to be sheet metal in this case. And I'll probably walk through how to create a template, but in this case, what we want to do is say, okay, let's go ahead and create a nest. Notice that now it's actually asking us what template do we want to select from. And that's going to be a really big difference, right? So when you create a nest from the nesting ribbon, it's going to automatically just, no questions asked, it's going to say, okay, it's going to start off with the default template. Whereas now we're starting off, inside of a part or inside of an assembly. Now we can actually specify what template to select. Now I have just the sheet metal nesting here. I can go ahead and say, okay. And again, it's going to start mapping all the different individual materials that we have here. And it's going to start extracting all those 2D shapes. So again, kind of going back to the rules on creating templates. So one of the biggest things that you can do in templates is have specific templates for materials, right? So if let's say you use a specific material pretty often, so whether it's certain gauge material, maybe a certain thickness aluminum, you can go ahead and set those templates, and then that way, you're always going to have those specific packagings, maybe even a specific sheet size for that as well, and you don't really have to spend any time or waste any time kind of making those edits inside the process material library. But in here, we can go ahead and say okay. And it's gonna, again, once again, automatically bring up all the extracted 2D shapes. So if we take a look at manage, one thing that I didn't really talk about was the providers here. So we click on providers. We can see what the so once you select the source, what is the nesting utility going to be looking for? So in this case, so it's going to be looking for DWGs, DXFs, Inventor assemblies. But once it gets down to the parts, it's only going to be looking for sheet metal components, right? So like I mentioned, you can extract composite parts, Inventor parts, generic CAD. It doesn't have to be, again, an Inventor part. You can bring in any STP file or step file. It's going to automatically pick that up. But again, it's going to follow those rules that we talked about earlier. But in this case, it's not going to look at any of these, right? So no matter what kind of part it is, it's only going to look at a specific sheet metal components. And again, that was created inside of my template. So every time I run this template, it knows to only look for sheet metal components, which brings up the next important point. You do have to have a flat pattern for the sheet metal components. So unfortunately, the nesting utility doesn't create that flat pattern for you. It does extract 2D shapes, so it's going to either extract some sort of a 2D shape if it finds some sort of a closed loop, but it's not going to create the flat pattern for you, and that's really where the user has to be diligent about making sure that each component has a flat pattern specified. So just something to keep in mind, right? And again, we can go here and kind of start going through some of the same process that we did earlier. So again, kind of looking at what's going on here, we have different materials. So we have aluminum 6061, different kinds of aluminums, galvanized steel, mild steel, different thicknesses. In this case, so let's go ahead and get a scenario going. So let's say we want to only focus on a specific material that has a certain thickness, right? We only want to go ahead and nest those specific components. So let's go ahead and go back into create here. Now, what we can say, I'm going to go ahead and just clear all the filters. Again, we have 38 shapes selected. Those are the entire 38 2D shapes that the nesting utility was able to extract. But let's go ahead and start applying some of these filters. So we can right click, we can say filter by material. And now we only want the aluminum 6061 material, right? So now it's only filtering these materials, but if you take a look at it, it's still picking up 38 shapes, right? So again, what you want to do is you want to clear all filters. And nice thing about the nesting utility is that it actually does have shift select capabilities enabled, right? So you can click on the top one, click on the bottom one, remove all of them from the selection there, and start going about it, kind of the same way. So we want to go ahead and filter out by aluminum, and it looks like all of them are going to be 0.065 here as well. So what we can say is, okay, let's go ahead and just select all the ones that are here filtered out. Right, so now we have 11 shapes selected, but if we clear all the filters, we see that all the other parts are still kind of in there, right? They're just not selected in this case. And so from here, again, we already have our parts selected. We know which ones we're gonna go ahead and select. So let's go ahead and click OK and just kind of generate that specific sheet. Right, so once again, it generates that nested part. And again, the thing that it remembered was the previous the previous packaging size that I had used, right? So again, it's still using that 105 by 50. We can go ahead and change that and say, maybe we want a 30 by 55 sheet. So what we would say is, okay, let's go ahead and figure out what my material is going to be. It's going to be material ID 8. You can go to the packaging here. And we can say, okay, so that one's going to be 55, and then we can say the width is going to be somewhere around. I guess we can leave it at 50 actually. So we can say okay, and then again, just remember to recalculate that nest. Okay, so we can leave it at that. And again, notice that it didn't create anything else. That was the only thing that it picked up, because again, we're only going to be nesting these 11 parts. And now what we can do is say, okay, same exact thing that we did on the other end, right? So select the sheet. Now we want to go ahead and say create 3D model. This time we're going to go ahead and create an assembly file just so that we see, what takes place. And a few other things, right? So what is the generation method? What is it going to generate? Do you want it to extrude the 2D shapes, or if the nesting for some reason brought in some sort of a 3D source, and it's going to try to use those if available. And then create instances for identical items. Do you want them separated in folders? Do you want them to create unique instances, even though that they're going to be the same part? Again, it kind of depends on what your workflow is. How are you guys going to be managing your parts? In this case, I can say I'm going to go ahead and create and group instances just so that we see the folders that get created, and say, okay. And if we take a look at where it created it, I think it was the desktop. Here. I think I didn't select the, I don't think I selected the folder here. So let me go ahead and select, create 3D model. Let's see here. We can do a new folder and say cam. Okay. Bring them in there. Let's see, okay. All right, so now if I open it, for some reason it's not bringing in the assembly that I wanted. All right, let me try this one more time here. Create 3D model, include stock, assembly file. Everything here seems good. Shoot 2D shape, okay. Okay, there we go. All right, so not sure exactly what was going on there. Should have worked both ways, because I was trying them both ways not too long ago. But anyways, kind of a overview of what happened here. So again, it creates the assembly file, and in that assembly file, it created the different components in here. But notice that each component is kind of living in its own folder, right? So again, it grouped the instances based off of whether it was unique or not. If it's not unique, or if it has the same components, so like let's say, I believe this one right here, which is going to be this cash can. Let's see where this one's going to be at. Okay, hopper handle. Okay, yeah, so it was supposed to create essentially the multiple instances kind of in the same folder here, drop down. But anyways, so that's kind of the two workflows that we're showing here, right? So we can either have a multi-body part. So again, this is just a single IPT file with 11 bodies in here, or we can have an assembly file with kind of the individual folders laid out. Kind of the end process, or the end goal is always going to be the same. It's going to be how are we going to manufacture the part. And again, that's going to come up to, what software you have available. So if you have, something that's embedded into your design software, then great, go ahead and use that. But often, a lot of times, another workflow is, okay, we're going to create the nest, and now what we're going to do is actually generate a DXF file, and then just let our laser or plasma machine kind of take care of that. But in this case, I do want to go ahead and highlight, kind of what the steps are to generating toolpath for this. And really what I like to do is I like to organize this in the sense kind of so that I follow the same path that I did for anything else inside of Inventor, right? So in the sense that I'm going to start working from left to right, again, starting off with our setup. And in this case, I want to say, okay, so I already know I have my stock created. So I can come over here to the stock tab and say from solid. And now it's going to ask, okay, which solid do you want to go ahead and select? I can go ahead and select that specific stock. And now for the models, right? So which models do we want to choose? Again, you can select all the individual models in there, but what you can do as well is you can go to the model tab and then select, let's see. This might work a little bit easier on the multi-body. And reason being, okay, so I'm just gonna go ahead and select a few of these just so that we see what happens, right? But again, I'll show what the multi-body, what we can do with that one. But for this one, and you have to do this step because again, you have to tell the software, okay, which parts are we going to actually cut or focus on. In this case, we're gonna select all of those parts. We can go ahead and say okay. And one thing that I forgot is make sure that you set your operation type to be cutting, right? Otherwise, if you do milling, again, we're not going to be doing any milling. This is going to be done on a laser. So you want to make sure that you set your operation type to cutting there. And now the next step, again, you don't want to focus on any of the 2D milling parts. You want to make sure that you do the 2D profiles here. So we can go ahead and select 2D profile. What kind of cutting is going to be? In this case, we're going to do laser cutting. Right, your kerf width, we can say it's going to be 70 thousandths. And now we can go over here to the geometry tab and say, okay, which contours are we going to select? And this is really what I like about, kind of the 2D profile toolpath is that we can say, okay, well, we want that contour selected, but we also want to make sure that we select everything else that's on the same plane. And again, that's kind of the power of having the nesting utility kind of generate that 3D model for us, is that it automatically generates everything evenly, right? So everything's evenly spaced. Now we can come over here and say, okay, I just want to go ahead and focus on the outer loops probably. If you have tabs, obviously you want to create some sort of a tab here just so that, it doesn't cut all the way through. You can go ahead and do that as well. And really you just have to go ahead and click OK, and it's going to automatically generate that toolpath for us. Right, so again, pretty powerful. What we can do from here is say, okay, well now we want to go ahead and post-process this. You can either select, a post that's already automatically built in. In this case, though, I am going to be using an installed post. And again, if you need help installing the post, or maybe there's you get a post modified and you need kind of a walkthrough on how that works, reach out to us and we'll be happy to kind of walk through that. But in this case, we're going to be using that Mitsubishi laser post, right? And we're going to go ahead and give it a name. And this should error out if I'm not mistaken. And it does, right? So a lot of people are going to see this and they're going to say, okay, well, what exactly is going on? And I kind of walked through this on a more CAM specified webinar. But really what you're trying to look at is going to be these error codes in the towards the end here. So one of the biggest ones that comes out to mind is going to be this radius compensation mode is not supported, right? So a lot of lasers, they cut straight on the profile that was selected, whereas some of the other ones, they actually have some sort of radius compensation allowance, right? So in this case, the Mitsubishi, the laser post doesn't allow for that. So we want to make sure that we account for that in the 2D profile. So in this case, if we edit that 2D profile, and if we go to the passes tab, change that to be the center compensation. regenerate that post or the code. And now it automatically generates that for us, right? So again, we just essentially created a nest and brought it into our Inventor HSM and automatically generated the code for it, right? So now really the last step is just to run the part, make sure that everything is correct. Obviously, you can go ahead and duplicate this toolpath and then do the same thing for the inner loops here instead of focusing on the outer loops. But that's more or less kind of the workflow that I wanted to highlight. And same thing for the other nesting that we had, right? So this is, again, just a multi-body part, but we're going to be taking that same approach in the sense that we're going to go ahead and start with our setup. And again, this is going to be a milling operation. So our stock is going to be a from solid. And again, it's going to be that solid that got generated. Which parts are we going to be focusing on? So in this case, what we can do is we can expand the solid body. So we try to click on these individual components. It wouldn't generate anything, right? So you want to make sure that you again click on that first initial instance, click on the last one, and it's going to automatically generate that for us, right? So our WCS, again, you can position that wherever you like. In this case, I'm going to leave it bottom left hand side there. I can go ahead and say OK. And I would probably use some sort of a 2D contour toolpath on this one, right? So again, selecting our tool, this is going to be a little bit more different. And again, I'm probably going a little too fast on the HSM portion, but just want to get the general overview of what steps to take here. So I'm going to go ahead and say I want to maybe a quarter inch end mill here. Say select, and you can kind of see your tool gets brought in there, right? And what you can do is also change the feeds and speeds, right? So have your tool library already set up for the feeds and speeds that you're going to be using. In this case, what you can do is say, okay, well, now we want contour selection, and this one is going to be a little bit more manual work. Unfortunately, as of right now, there isn't a kind of a quick way to select some of these contours, right? So just one thing to keep note of when you're kind of going about this, creating some nests. But we can say, we want these contours. In this case, we can say we want some tabs as well. If we zoom in here, again, the great thing about this is that it gives you a kind of a live preview of the tabs kind of here being generated. You can say, okay, I want these tabs to be spaced out every 7 inches. Maybe the tab width, make them 0.5. And we can go ahead and say okay. All right, so we take a look at the toolpath. We can actually see the toolpath creating those tabs. Now again, this is wood, so this toolpath might be okay, but for some people that might be a little bit too aggressive. So what you can do is actually ramp down into the part and say, okay, now I want maybe some sort of a 1 degree ramp along the contour. And now instead of actually plunging in and kind of going full depth, you're kind of slowly working your way down into the actual part, right? So again, same thing here. You would just go ahead and post process, select which post. So you can either select either a Fanuc post. I do have another post in here. I'm not sure if this one is gonna generate anything, but we can give it a shot. Desktop. Yeah, so here's the other post, right? So again, probably a little bit more of a unique machine, but nonetheless, it did generate some sort of a code here that the machine is going to be able to read. Okay, so I know that was kind of a lot of information to go over, but hopefully we were able to highlight at least a little bit of of what takes place inside of this workflow. So again, if you guys have any questions, this is probably a good moment to ask. If you guys are watching this online, or maybe another question comes up down the line, write down our email, give us a call, or shoot us an email, and we'll be happy to walk you guys through some of these.
Yep. There's a couple. Let's see here. Orientation for grain.
Yeah, so that one actually, so I have seen an option in there that essentially allows for grain orientation, but I'm not sure that works as we would expect, right? So again, if you have a part, you have your Inventor appearance, you can essentially allow for grain direction. I don't think that's going to behave as as you would expect.
Right.
Reason being is because that's a little bit more advanced functionality. For something like that, you would probably require TrueNest, right? So if you want to allow the grain direction to change based off of how you want to nest it, I think that's going to be a little bit more advanced.
Yeah, what I would do in that case is just like disallow it to rotate when it comes in.
Yeah,
that'd be the only thing you could do.
Right.
Is you want everything to be consistent, I guess. If you want it to be consistent, then disallow the rotation of those parts so that they're all facing the same direction and they're not flipped or rotated at all in the actual nest. That would be one way to control that, I guess, on a more manual level.
Yeah, a little bit more manual work.
Let's see. Same thing. How do you tell in the nest which side is top or bottom of a part? They're allowed to flip at free, like just freely, unless you turn that option off. And that's like when you're actually creating the nest, you can choose to let the part rotate or flip. If you allow it to flip, then it could be the top or the bottom. If you don't allow it to flip, then it'll be the top. Let me run through this. How do you move the settings to multiple machines? So I guess the question there is like, how do I move the nesting templates over and the cam templates and the tools, and so on and so forth. So the nesting templates is just a nesting template file.
Yeah, it would just be right. And let me just show where that would be located at.
Yeah.
But essentially what we would do is we would say, create new file. If we kind of work our way down here, we have a standard nest. So that's really where I would recommend starting off. We can say start off with the standard nest. And again, this is just your general kind of your template file that you're going to start off with. And again, you want to make sure that it's blank. And in here, kind of going back to what I was talking about, the providers, notice that as of right now, it's going to allow for all the multiple providers to be picked up or extracted. Again, if you're going to do a sheet metal only template, I would just go ahead and deselect those. Maybe even deselect some of these DWGs, DXFs as well.
Yeah.
Just to make things a little bit easier. But that's what I would do. Say okay. You would come in here and create your materials as well.
Yeah, your standard packaging for whatever you guys are all using.
Yeah.
I would create them all in here, and then once that's done, this file is on the machine, and then you just move it into the other machine. It's in your templates folder, so just.
Yeah, that's going to work just like any other template, right?
Yeah.
So even if you have a vol, you can just have that kind of in your own specified templates folder, and users are going to be able to pull from that.
Exactly, and then with the tool libraries and stuff, Alex, to make sure that everyone's using the same one.
Yeah.
Same concept.
Same concept there. Yeah. So and we talked. I believe we might have showed this in a previous video, but yeah, same concept, tool library. If we go over here, we can say we want to add a library folder. And in here, you would specify, first, obviously, you would want to create your folder where you're going to store all of your tool libraries. But same concept, you would either have that in a shared drive so that all the users are going to be able to pull from those tool libraries.
Yep.
A coworker and I actually tested out the Vault capabilities with the tool libraries. It does get a little tricky, so I would, if you guys want to allow for multiple people to make edits to the tools, or to actually add or create a tool on the fly, you might start running into some issues. But if you have one specified person that kind of takes care of all the tooling for you guys, then working with a vaulted tool library would be no issue for you guys. Otherwise, I would recommend just do a shared drive and have that tool library there.
Yep. Makes sense. Let's see what else. Question here: would those generated codes work for every machine? What about old ones? So no. So these codes won't work with every machine, right? Every machine is going to use a different post. So it is all specific to the machine that you are using. There are, I don't even know how many posts there are now.
There are a couple hundred posts, yeah, that you can already select. And if we go back to,
did you close it? Oh, there it is.
Yeah, I think this one. There it is. Okay. Yeah, so post process. And again, this, I mean, when I hit the drop down, I only have access to these two posts, and that's because I'm, again, in my personal posts. But if we go to the installed post library, which is essentially all the posts that are, that are installed with Inventor HSM, you have a list of just hundreds of different posts that you can use. For the most part, I mean, a lot of routers are Fanuc based. Obviously, that's not going to be the case for for every machine out there, but that would probably be your first step, is figuring out what controller does the machine run on, and then from there it is does HSM have a post that's somewhat similar to it, and if it does, then what we can do is start modifying the post so that your machine can read the specific code generated.
Yep.
So there's a workflow to that, again, and that's only if you don't see your post.
Yeah, if you have like a super popular machine, then the odds-on chances that the post already exists.
It's going to be in here.
If not, then yeah, you're going to have to find a post that's similar, or you're going to have to edit a post or generate one to work with that machine. So
yeah, you can go to the Autodesk HSM post library. So I believe they have another, just a couple more added posts on there that aren't on the drop down. So what you can say is you can go to the water jet section, and you can kind of start seeing the different posts that that are in here as well.
Absolutely. Let's see what else. What version of HSM are you using, Alex? That's a trick question, isn't it?
Yeah, it is a trick question. So I'm using Inventor Cam, and that was actually released as of as with the 2020 version
of Inventor. Yeah.
Yeah. So Inventor Cam, that's
yeah. It's not. When you're looking at new versions, it's not called HSM anymore, Inventor HSM anymore. It's called Inventor Cam now, just to make it a little bit easier for you. It's still the same exact thing as HSM was or is.
Yeah.
But in regards to different versions of HSM, Alex, I think Alex, what he was doing, you could do in any version of HSM if you were using like an old version.
Yeah. Yeah. So if
it's only 2D, right?
Yeah, because it's only 2D profile. Yeah. So if you guys are Inventor HSM 2019. Again, you should have capabilities to do 2D profile. The only thing that you would require, obviously, is going to be the nesting, the nesting utility. That's really the biggest, kind of the biggest.
Yeah. So if you have the nesting utility, you have the full version of HSM. So like,
yeah, pretty much. Yeah, that's safe to say.
Jeremy, could you clarify a little bit? Could you set up details for plasma tables? Just wondering what you're looking for there.
Set up details for plasma table. That might be like I think he might be talking about like the NC code, how you have kind of like you have like the top layer or the top section, that's going to be generating setup details there. That might be what he's talking about. And that, Jeremy, would be taken care of in the post. So if you just want comments to be outputted, like let's say we have stock size, or maybe you have a specific sheet that you're working with. That can all be taken care of inside of the post.
Absolutely.
So yeah, so that's what you're referring to. That's possible.
Josh asks, can this handle 5-axis water jets or plasma cutters with bevel heads?
Ooh, so that would probably be a little bit more.
That would be like a cam question for sure. I don't think you could go with the nesting stuff. I'm pretty sure it's a consistent. You have to have a consistent thickness.
Yeah, but if you have if you have a beveled cut in here, and you kind of want to rotate the head of the machine, that might get a little bit more complicated, being that this 2D profile doesn't have any options for that. So one thing that I haven't looked at is how to if it's possible to properly use a 3D contour toolpath. But that's going to start getting a little more complicated, because then this contour toolpath, you can actually start modifying, the tool orientation and specify how you want the head of it to tilt. But yeah, I mean, that might get a little bit too complicated. As of right now, I would say, I would honestly say no. And that's because the 2D profile, the specific actual 2D profile, that generates, you know, these different types of cutting methods, it doesn't have capabilities for 5-axis.
Yeah, and the 5-axis stuff doesn't have water jet, plasma cutter.
Yeah,
capabilities.
not yet. I think that would be. I think that would be a little bit out of scope for this software. But that's a good question, though. I'll definitely I'll look into that one because I am a little curious myself as well. Because if it was a router, a router would
yeah, if you
okay.
use a router, it's fine.
Yeah.
But if you're using a water jet or a plasma cutter, it's probably
that might be a little bit too
not fun there. I think that's just about it for all of the questions that we have. I'll give everyone another 30 seconds or so to ask any more. And Alex, anything else to add before we hop off here?
No, I mean, we have a, kind of a survey at the end. So let us know what you want to watch next. If you guys want, are interested in a little bit more nesting, maybe go a little bit more into details or watch the entire workflow where we actually design a part. Yeah, let us know if what you guys want to.
I think if there's one key takeaway from all of this too, it's like Alex never left Inventor.
Yeah, that's going to be
he's an Inventor the whole time, as opposed to having to export DXF files, having to move from one program to another to be able to get to both nesting and the manufacturing side of things as well. It's all built into your Inventor workspace. The key thing, right, is if things update on one side, they'll update on the other end. For a lot of it, not all of it.
Yeah.
But for a lot of it,
least,
for a lot of it, if not almost all of it, it'll update. So just keep that in mind too. It's like a really big time saver for a lot of people, as we found out as well. All right, with that, again, thanks everybody. If you have any other questions, our email's there at the bottom of the screen. Please take a screenshot as fast as you can before I end this. Everyone, thanks again for joining us. Alex, again, thanks again for being here this morning. And we'll see you all next week. Thanks.